to Science Talk. I am your host and resident oceanographer Jim Massa.
Well, good evening, everyone, and welcome to Environmental Coffee House. It's great to see you, Jim Massa. Welcome to Science Talk with Jim Massa, oceanographer extraordinaire, who I have learned everything about the ocean. Well, don't laugh, because I didn't know jack shit. I met you, and here we are. I know so much more, so it's great. And it's great to see everybody out in the audience. Billy Joe, Jean, Kim, thank you for moderating. Nina, Thomas, Wanda, everybody. This is great. So what's been going on, Jim, besides the Twitter wars?
Not much. Where the mosquitoes are now out in full. So, first of all, hello, everyone. Welcome. We've had some interesting hailstorms this week.
Really? No shit. How big?
Probably a centimeter across in diameter.
Ugh.
And they were bouncing around, hitting the ground and bouncing. It's
Ooh.
like,
Were you walking outside? Did you get hit?
no, I was about the house there, but it was a lot of strong winds, and we've had a bunch of thunderstorms in addition to that, loud boomers and stuff and so forth. So it was entertaining earlier this week.
I guess. Wow, entertaining, huh? Well, we had what did we have? Guys, I'm going to try to flag your questions for later, by the way. We just had weather whiplash. It went hot. It was freezing. I mean, literally freezing. We had a frost a couple of weeks ago, which totally damaged my baby plants, and now I'm babying them to put them back, to get them to grow. I talked to them, please grow. And next week we're having a heat wave. We're supposed to get up to 97F here in June. 3 days of 90-degree weather. I'm not happy about it, but who is? So I made a meme for our local community page about preparing your animals, and I posted it, and nobody seemed to get mad at me because they're very red here. So,
Well, that's one of the aspects of climate change is the extreme swings in weather condition. One day you get a foot of snow, the next day it's 68 and it all melts.
yeah, no shit. But it's very hard to be a grower anymore.
Yeah.
To do it, it's very, you have to really, really
and
watch everything.
depending on the plants you're growing, you have to be careful with the high temperatures, because if they're C3 plants, they're not going to do well
No.
at temperatures approaching 100F.
Yeah,
They're
I
just
hear
not.
you. Well, my cool weather crops are almost done. I had kale and brassicas, and I took all the leaves, dehydrated them, and made them into chips, which are so good. So they're already. I'm almost done with the peas. Those things are pulled, and the hot weather crops are in the garden, which is a whole big thing. I busted my ass, and now I hurt my shoulder, so I can't finish my job. But yeah, you're right. You're right. You can't even grow much up there unless you do it in a greenhouse, right?
pretty much. You know, interior not so. You have to go to what's called the Wasu Valley, the Matsu Valley, the
Yeah.
which is Matanuska. That's like the Wasilla region. You know, down that way they have.
Oh, where
That's where
what's her
you
name's
see.
from? Sarah
Yeah,
Palin. I can see Russia from my house.
yeah,
Oh shit.
yeah. But
Yeah.
that's where you get the huge zucchinis that are basically
Oh,
airplane torpedoes,
wow.
and bombs. I mean, necessarily these things are like coming at 50, 60 pounds, or whatever.
Mine never do that. Damn.
Well, 24 hours of daylight that kind of
Yeah,
helps.
I guess. Yeah, they're constantly getting. Wow. Well, you can do that inside, I suppose, but wow. All right.
And you see
Well,
the pumpkins later on.
nice.
You need a forklift to pick up those damn things.
I can't say I've ever needed that. I have a cart, garden cart. All right. Well, listen. What I'm going to do is we're going to introduce the show now. We're going to start with the Alaskan rust. So hang on, guys. I'm going to cue up this video, and it's quite something. So hang in there, and now we're going to start.
What we're looking at here is you can see the discoloration in the water. You can see the effluent moving through. I mean, look at that. That's just absolutely incredible. It's not. That ain't how it's supposed to be. And these aerial views showing all the discoloration. Got some. You see you can see the discoloration in the water there. There's some scientists in situ, uh, you know, conducting the research. And this map here will show the locations of all these so far affected areas. All these little dots represent study sites. Anaktuvik Pass is right there in the gates of the Arctic. That's what the water's supposed to look like. That nice blue. Here you can see the permafrost thawing and melting away. More discoloration. I mean, look what it's already doing. What it's doing to the rocks. Definitely staining of the rocks. You can see where it's mixing. Right there. There's the where it's mixing. Some instrumentation taken measuring the parameters. Looks like an Arctic char. Probably taking testing out its health or something. More aerial views. Look at that. This is incredible. Absolutely incredible and very, very disturbing and alarming.
Well, I would say so. And here is the article. We're not going to read it because Jim actually did a comprehensive show, and you can see his comprehensive show on his channel. I just made that little clip. Jim, why don't you tell us really, besides that, what the hell is going on up there?
Well, it appears that this is yet another manifestation of global warming, believe it or not, because it is we know that the global warming is causing the permafrost to thaw and
Yeah.
melt where there are ice lenses in there. What's happening is that the thawing is leaching out metals.
Ugh,
It's leaching
my
out
God.
metals from the soil into the water, and at the same time it's reducing the pH of the water to extremely acidic levels, pH around 2.3 or so,
Yeah.
which is I'll have some comments to make about what it does to organisms on that. But when you lower the pH, that helps put metals in solution. And a lot of that, and plus a lot of that, what you see in that those colors is the oxidation of iron, primarily, but there are other metals going to solution, and that's what you see happening. That's pretty much what they're citing as the cause is the thawing permafrost leaching out the metals, the lowering the pH, which increases the solubility of the metals in solution, and you get orange waters.
Oh,
That's just really,
what's it
you know,
doing? Go ahead.
well, physiologically, first of all, acidic waters is a physiological stress on organisms,
Hmm.
so it's going to negatively impact the organisms. They showed some fish swimming around in there.
Right. It's
Many,
like corrosive to them, killing
yeah,
them. It's going to kill them with all
many
this zinc, nickel, copper, cadmium.
Many years ago, I actually did a histological study
Hmm.
on the effects of dichromate salts on brook trout fingerlings, because dichromate salt is a common ingredient or a compound that's found in the effluent of leather tanneries. And tanneries were a big thing in like northern New England, New Hampshire, Maine, that kind of stuff there. So dichromate salts were being released into the waterways, and it was killing the fish because they absorbed that material, and it was causing um, sloughing of the gill epithelia. It was causing problems with their kidney, the liver.
Mm.
Uh, Basically, you have problems with those three things, you're pretty much dead. And so, with the animals being exposed to the metals, it's probably going to do similar things. Probably going to start impacting like the gills. And I suspect when you saw the scientists having some fish samples there, I
Hmm.
suspect they're going back to do some histological examinations, looking just for that kind of deal.
What about the rural communities and the drinking water? I mean, it's treatable or not treatable?
It you can put in very extensive and expensive um, filtration systems
Hmm.
where you have to have reverse osmosis, and you got to have you know filters that go down to the microns to pull out the ions and so forth.
Wow.
You're almost talking about major water treatment plants, but yeah, this will impact the subsistence folks, because if the waterways are fouled up as we see here, and if a lot of them go fishing, the fish may not be appropriate for
Right.
consumption.
Right. And so also the permafrost melting is releasing the metal ores that were locked up, right? So
Yeah,
that's another
it's
yeah,
putting
that's
it into solution. It's putting them into solution, and that's why you see the staining. It's being leached out, and it interacts, oxidizes, and it stains the rocks. And then what doesn't stain the rocks goes in the water
Is this
and discolors the
happening?
water.
Is this happening anywhere else in the world? I mean, is it unique to Alaska, or is it happening, let's say, in the permafrost in Siberia, for example, which there was so much industry there? Is this happening there?
I don't know, but it wouldn't surprise me. You know, the only thing that I can remember similar to this was, and I mentioned it in that video, is what happened to the Animas River, which goes through Durango, Colorado,
Mm-hmm.
and there a couple. About, yeah, a couple of years ago, 4 or 5 years ago, something like that. It turned orange, and but
Yes.
basically, if you go about 50 miles or so north of Durango, you come to the mining town of Silverton.
Yeah.
Mining town. So
Uh-huh.
what happened was some like slough pond, whatever, like busted, and all
Yeah.
that crap just went into the river.
I remember that. Jennifer and I did a show on it. She lives in Colorado. Yeah. I remember it. So yes, I should have known that. Should have known that. But it seems more serious because it's all over Alaska. It's all over your state. It's happening everywhere.
It appears to be on the north side of the Brooks Range for sure, where you have a very strong concentration of permafrost. Because that permafrost, you get on the north side of the Brooks Range, permafrost can go down several hundred meters.
Right.
You know,
Wow.
and it's called
Wow.
continuous permafrost, not like discontinuous permafrost.
Wow.
It's so, and you saw on that map there, all those little yellow dots there were all
Mhm.
the sites. That's extensive
Is that on
because
is that in the article? Is a graphic of those
yeah,
maps? Let me see. I'll
it's
pull it
it's
up.
in that it's in that little video that I played with it. But keep
Oh,
in
it's
mind that
not in the article. Okay.
it's the figure there. It
Mhm.
shows all these location. But
Mhm.
keep in mind, you get on the north side of the North Slope,
Mhm.
and you're going all the way up to the Arctic Ocean. That's the size of Montana.
It's a lot. Wow.
It's a big
Wow.
area, and to be that widespread is really distressing. Now, if those streams there, as they make their way to the major rivers, be it the Yukon, the Noatak, the Porcupine River, what have you, the Chandalar River,
Yeah.
they start making their way into those major rivers where salmon do their spawning runs. It's a whole different ball game.
Well, it seems like it's going to be a whole different ball game. Not to sound like a doomer, but if it's in so many places and proliferating, wow, and melting. I have a question for you I think about often. You live in Fairbanks. Tell me something. Is the permafrost you're built on permafrost. You're living on permafrost.
Yeah.
Is it going to affect your home? Is it affecting your home?
Oh, well, it's affecting the garage. The garage is kind of sinking, so it's always
Oh,
messing my because well, when I built the house, I built it up on post and pad, so I have an airflow. It's kind of hard to do that in a garage because you need a ramp to go in there,
okay.
and don't feel like driving up a 40-degree ramp, like
Okay.
to get into the garage. So I kind of
Gotcha.
used pressure treated wood, built it on the ground, but insulated the floor, but still it's. It sinks and settles and it messes up my garage doors, which are homemade. So, yeah.
Wow. Yeah, I thought about that, especially
In
when we
fact,
were.
I
Go
spent
ahead.
today actually taking off one of the garage doors and trimming it down a bit, so,
Really?
so so that it wouldn't bind up on the sill.
So things are
Um,
really changing like that. Wow.
oh yeah,
Well, I think they're changing here in respect to some of the structure for my house also. I mean, because nothing's the same. Like the back door, nothing is level anymore or even. The property has changed in 10 years. It's rocky where it used to be not. A lot of rocks coming up in the ground. And I think that might have been from the years of drought, which it looks like, who knows, this year, because we don't have any rain in the forecast now for another, I don't know, week. And then we got that heat wave coming up. So I'm glad I have that water. I have a rainwater catchment. Glad I have that filled.
how deep is your frost line?
I have no idea.
Because you could be seeing frost heaves bringing up the
Oh,
rocks.
really? That's interesting. Well, here's another area of inquiry. I'll have to look at that. How deep is the frost line? Could be. That's really interesting, Jim. Holy shit. No, I would never have thought about that. So it could be
Because
from.
especially in the Northeast, when you're building homes, especially like digging a basement or putting in, say septic fields and leach
Yes.
fields and that kind of stuff there,
Yes.
you have to make sure you go below the
Below it.
frost line.
Okay. Yeah. hmm And I have septic. I'm a septic person. If that fails, I have an outhouse. I'm trying to prepare myself for who the hell knows what. All
So
right.
that's why I have an electric toilet.
Yeah,
I
I
don't have to
know.
worry about shit freezing and backing up.
Right? I know you've talked about that, which I think is actually kind of cool, to have that. I just have in my outhouse. I mean, I have a regular house, but in the outhouse I just have a bucket I mean, it's got a built-in seat and all that. It's quite nice actually, but I just use a bucket. I didn't put a hole in the ground. And then there's you manure compost. I have three different kinds of compost on my property. It's just insane. A lot of work.
Do you,
But
do
it's
you use lime?
no,
No.
no, I don't even. It's not even that bad. Because it's like it's not like I'm using it and I have 50 million people using it all the time. I use it when I garden so I don't have to run in the house. You know, I don't have to take off my shoes and check for ticks and all that other horse shit. All right. Well, we're going to move on, even though I know everybody likes to chit chat between you and me because it's fun. You know, it's always fun to be together with you on a Friday night. But we do want to move on to the next article because this is the European Geosciences Union. Hang on. Okay. You wanted to talk about this, and you have to forgive me because usually, guys, I study. For my shows with Jim, I study for days and I learn everything, and it's insane. It's like taking a college class. Holy shit, I didn't have time this time. So, Jim, take it away, baby.
Well, I'm just going to go over the abstract on this in the next article we're going to discuss. I will be doing deep dive videos on these two articles,
Good.
so it will happen. But
Okay.
I will get around to it. But the reason why I wanted to discuss these two articles was because, again, I'm going to push back against this aerosol bandwagon that everyone seems to be jumping on.
All right.
And so leave that in there. So, okay. So the European summer weather linked to North Atlantic freshwater anomalies in preceding years. Okay. So again, I'm just going over the abstract.
Mm-hmm.
Amplified Arctic ice loss in recent decades has been linked to the increased occurrence of extreme mid-latitude weather. They say the underlying mechanisms remain elusive. However, one potential link occurs through the ocean as the loss of sea ice and glacial ice leads to increased freshwater fluxes into the ocean. Okay, how many times have you heard me say this?
Yeah. It's okay. You could tell us again.
In this study, we examined the link between North Atlantic freshwater anomalies and European summer weather. Combining a comprehensive set of observational products, we show that stronger freshwater anomalies are associated with a sharper sea surface front, temperature front, between the subpolar and subtropical North Atlantic in winter. That is an extremely important statement. The sharper sea surface temperature front between the subpolar and subtropical North Atlantic in winter. Translation, a very strong gradient. You get cold temperatures on one side of it and warmer temperatures on the other side of it.
Ooh.
You get also an increased atmospheric instability above the sea surface temperature front and a large-scale atmospheric circulation that induces, this is really wild, a northward shift in the North Atlantic current. Now, the North Atlantic current is that section of the North Atlantic gyre that goes across the Atlantic Ocean
Mm-hmm.
from
Mm-hmm.
from the North American side over to the European, Southern European, and the African side. Okay,
Oh.
so
Is there any
that's
graphic?
the north. That is actually being shifted northwards.
So there's no graphic here that we can use that will give. No, this
No,
is
no,
really not a graphical article, is it? Okay, we just have to
no.
listen and imagine in our minds.
And what that does is it strengthens the sea surface temperature front. In the
Ah.
following summer, the lower tropospheric winds are deflected northward along the enhanced sea surface temperature front and the European coastline, forming part of a large-scale atmospheric circulation anomaly that is associated with warmer and
Oh,
drier weather over Europe.
really? Huh.
Okay? And basically what they're saying is this works in conjunction with the North Atlantic Oscillation. The identified statistical links are significant on time scales from years to decades and indicate an enhanced predictability of European summer weather at least a winter in advance, with the exact regions amplitudes of warm and dry weather anomalies being sensitive to location strength and so on. So, what are they saying? They're basically saying that the influx of fresh water is changing the situation. It ain't
Right.
aerosol. You hear people saying, "Oh, Amoc is shutting down because it's heating up the water." Well, first of all, that's not correct. Um, Aerosol, if it has any impact, it's on atmospheric temperatures. It's not the oceans. And what the people who keep pushing the aerosol narrative do not remember or choose to forget or what have you is that at northern latitudes, sea oceanic density is determined by salinity, not temperature.
Right. And we've talked about that before, and I made it my business to learn a lot about that. Mm-hmm.
So you're dumping in fresh water. What's that going to do? That's going to drop the salinity, which means it drops the density. That's
Right.
why you don't get the deep water formation. It ain't the temperature reach and heating up that's bollocks.
But
And
the
first
te-
of all,
but the oceans are heating from
the oceans are
absorbing the
heating.
CO2.
There's a different mechanism for that.
Right. Right.
Okay, first of all, remember that the specific heat of water is
Mm-hmm.
about more than 4 times greater than that for atmosphere. If atmospheric scientists are saying that the the result of a reduced aerosol is an air temperature increase of 0.42 C
Mm-hmm. Mm-hmm. Per century.
per century, how the hell is that going to jack up sea surface temperatures by 5 to 7 C over a year or two? Come on, especially with the given specific heat differential.
Come on.
And the other thing is, really, I get so annoyed
I
seeing this
know,
stuff here.
hun.
It's just like you guys are forgetting basic physics here.
Well,
They're
you have
just
to learn
latched
basic
onto.
physics in the first place. A lot of us are not. That's why we rely on you to teach us this. The
But
simpler.
these are so-called professionals.
I know.
You know,
I know. I know
but
you get
but
upset.
the thing is, okay. So sunlight energy makes a way through the atmosphere. First of all, the the angle at which the sun penetrates the ocean is a function of latitude. No, and so know that the heat that comes in is going to differ by latitude. And what you do is you take the cosine of the angle. It gets all technical.
Hmm.
The point is, you've got X amount of watts coming in. Okay, the only way you're going to absorb 100% of that X amount of watts is at the equator. When you get up to the curvature of the Earth's surface, it comes in at a deflection, so it doesn't
Oh,
get absorbed. And the
right.
other thing is, the assumption is you have a smooth surface. Well, the North Atlantic is anything but calm usually. Okay, sometimes it is, but not usually.
No.
So you have choppy surfaces. The ability to absorb in directly insolation coming from the sun energy is extremely reduced. And add on to the fact that heat energy attenuates very quickly in the water column, following a very fast exponential decay function. So the amount of reducing the aerosols, the amount of added input to the ocean is not going to be that much greater from reduction of aerosol. Why are the oceans warming up? Because we keep dumping greenhouse gases. That's what it is. And what are the mechanisms? Well, we're now finding out that mesoscale eddies are the mechanism by which heat energy and CO2 gets entrained into the ocean.
And we went
And
over all of that on the last show we did together, and I had all the graphs and the graphics for the mesoscale eddy and learned what they were. And you all should have also.
And just a quick cap. And you look at the Gulf Stream; it's not just this little ribbon there. It's got all these little meandering, eddies that pinch off and so on. Well, when you look at the eddies that pinch off, you get
Mm-hmm.
some that spin counterclockwise, you get some that spin clockwise. Well, the ones that spin counterclockwise actually create an upwelling in the middle of it. So those little mesoscale eddies will actually help move material from the oceans to the atmosphere. The ones that spin clockwise has a downwelling. They bring materials from the atmosphere into the ocean. So then you have to do the calculation, what are the size of the eddies, what's the exchange rate, the flux rate, and so on
Right.
and so forth. But what we are now seeing is when you calculate the net, not only in the North Atlantic, but the Southern Ocean, what have you, when you start calculating the net is the ocean heat that's in the oceans is now having a net movement to the atmosphere,
Wonderful. So yeah, it's a
which is enhanced
right.
by El Nino. When there's an El Nino situation, more heat gets dumped into the atmosphere. La Ninas tend to draw down heat, but the rest of the ocean still dumping heat out
So let me
into
ask
the
you a
atmosphere.
question. Maybe this is going a little off, but with the El Nino, are we going back? Are we going to get out of this and get into a
El,
little bit of a different La Nina situation
El
this
Nino
year?
has officially
It did end.
ended, and the indications are we're moving towards a La Nina.
All right. Although I don't know, is that any better these days? Well, I mean, look what.
Remember, the coldest La Ninas of recent years is still warmer than the hottest El Ninos of 30 years ago.
Say that
Remember
one
that.
more time. Say it again.
The coldest La Ninas of recent years, that's like
Yes.
the last two,
Yep.
3 years, is still warmer than the hottest El Ninos of 30, 40 years ago.
Repeat after me, folks out in the chat. Yeah, but it's not even funny. It's actually pretty fucking scary. I mean, and so tell us. I know we're segueing a little bit off this, but it's still oceans. Did the oceans have anything to do with the insane rain in South Florida and the flooding? I mean, that we just
Oh,
saw.
you got all that heat just being
Yeah,
dumped into the atmosphere, yeah. And of course, the warmer atmosphere can hold more moisture, and
and that's
you
what's
get the
happening.
warm front meets cold front, and hello,
Yeah, and
we
it's
did a
not
we did a
a
precipitation results.
and not a marriage made in heaven either. Oh, jeez, wow. So it's been pretty hairy, down there for the people, and they have
Oh,
a
oh, oh,
governor
oh,
that
it,
struck
it's
climate
just
change.
starting, folks.
I know.
It's just starting. It's going to be one hell of a ride from here on out.
I keep begging my mother come up here for hurricane season, and 90-year-old mom doesn't want to leave her Florida
Oh,
house.
with the La Nina, that is what the indicators are that's going to be happening
Yeah.
because of the teleconnection. The Atlantic
Oh,
hurricane season is going to be a doozy.
I'm
And
scared
then you
for
add
her.
and then you add in the ocean heat content, you're going to see Cat 5s all over the damn place.
She doesn't want to come here. Folks, if you have relatives that are elderly that live in Florida, try to get them to leave. But it's not. People don't. It's not that she doesn't believe it. She's just thinking she's invincible. But it's tough when they beat cancer 3 times. She's 90 years old and she has a big social life, much more than I have. And she's like, "No, my house is fine." Even though it rained, it was like Noah's Ark. But anyway, oh my God. All right. Well,
But but
enough with.
again,
Yeah.
it's what we're seeing is the freshwater dump,
Yeah.
and to me the really and I've already done a short little video on that section about the North Atlantic current. I got to edit it yet, but of moving
Okay.
northward. That to me is a really important result and very telling result. There's already been indications that the gyres have shifted a couple of degrees north, but now we see that this whole current has just moved a quite a few degrees northward, and that is going to really change weather patterns across Southern Europe, Central Europe, the UK, the Scandinavian places. It's going to change things drastically.
And in what way? Give us the examples, like for the UK,
Well,
for example.
well, the southern Europe, they're going to have warmer, drier condition. Well, if this subpolar front
Mm-hmm.
moves northward, you're going
Mm-hmm.
to have cooler conditions and probably wetter conditions for the UK, as though they can't get any wetter already. But uh, and Scandinavia. So Scandinavia is going to probably see more snow into May and June, you know,
Okay.
as well as cooler
Well, then,
temperatures and stuff like that.
so a lot of the people, I have a guy that writes to me, and he's in Scotland, and he's convinced that there's this that global warming isn't happening because he gets colder winters, different winters. I've tried to explain to him. I said, "How long have you been following?" And you're still writing me this shit after like 6 years, I
Well,
think.
what's happening there is also, a manifestation of the
Yeah.
slowdown in deep water formation. And you have heard me say that overall global warming is happening, but places like the North Atlantic,
Yeah.
where UK and Scandinavia are going to feel cooler effects because of the slowdown in the Amoc. And now with this sharper gradient in the sea surface temperature fronts,
Mhm.
where we're basically starting to keep the colder sea surface further north and the warmer sea surface temperatures further south. You get that
And
sharp gradient. That's going to further amplify that thing. Now, there's something else I want to mention, and this is kind of a weird thing. If I was to ask people,
mhm.
maybe people can put it in their comment.
All
When you
right,
say
I'll put
sea
them up.
surface, when you say sea surface temperature,
Mhm.
where do people think it's being measured?
Oh, okay, I'm not answering because I already know. All right, guys, where are they measuring? Where are these scientists measuring, or the governmental organizations? Where are they measuring the sea surface temperature? I don't want to tip my hand. Come on, let's see what the chat says. I wish I had the do 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 do. I have, what do I
I mean, the
have?
Jeopardy music.
Yeah, I keep saying I have to. Here. Okay, Scott says 10 meters deep, and Devon says 1 foot deep, and I don't know. Come on, guys. All right, well, we're not getting all right, I guess it's time for Jim to. Oh, Jean says she assumes at different levels of the surface range to get an average. And David says 3 feet. All right, we're done. Let's hear what's really
Well,
happening.
this is a problem in oceanography, and this is something I've been trying to get a standardization of. There is no standard. It can be anywhere from 0.1 millimeters
What?
down to 20 meters. There is no standard for sea
Oh,
surface temperature measurements, and this is a problem.
Elliot know
Now,
that? I
now,
mean,
when you have the
yeah.
satellites going overhead, okay, depending on what aperture they're using and the wavelength they're shooting at, all that kind of stuff, they're typically just measuring the skin,
Oh,
right there at the air water interface. They're measuring
no
that first
shit.
0.1 millimeter, that 1 millimeter.
It's like
So
nothing.
when you see these graphs of the sea surface temperatures off the chart, okay, yeah, it's a cause of concern, but it's usually from satellite data, which is looking right at the skin.
Okay, so what data, let's say Dr.
So
Elliot Jacobson, who is always updating his sea surface temperature
he's
maps.
if he's using Copernicus, that's pretty much satellite data.
Okay.
And I'm not faulting Elliot. I'm just
Oh, no,
pointing
no, no. We
out.
wouldn't. We love Elliot. Oh, no.
No, Elliot does great things. I mean, I'm not saying he's wrong. I'm just pointing out
Yeah.
that that's what that's measuring. Of course, it doesn't take into account the heat flux from below. as
Yeah,
the heat
that's
from the ocean moves up.
right.
Now you have a whole bunch of Argos buoy systems all over scattered all over the ocean,
Right.
and some of them measure it down to 20 meters. And as Gene said, perhaps you do an integration. You integrate from -20 to 0,
Okay.
and then take the average value of that, which is 1 over b minus a, right? And you take the average of that, and that's your sea surface temperature. But 20 meters, in my view, is too deep. What I think it should be is if we measure air surface temperature,
Mm-hmm.
and there is a standard for air surface temperature, it is at 2 meter height. So
2 meter
2 meters
height.
in the water.
Oh, I
You know,
see.
we
Up
so
and measure down. Hmm.
if we're taking 2 meters above the ground for air surface temperature, and we call that air surface temperature,
Yeah, I gotcha.
then take 2 meters
Yeah.
in the ocean.
So why don't you write a paper and get it standardized? Become famous, Jim.
Um,
Write
but
a book. Write a book and hawk it all over CNN. Yeah.
Who's that idiot off from
Oh,
Alaska? What does he know?
oh,
Yeah,
yes. Stop.
yeah. But in all seriousness, so there is no standardization. But
No
when you're
sense.
looking at the satellite data, keep in mind they're looking at the upper 1 millimeter.
Okay. But
So if you want to get the sea surface temperature down to depth, you have to go to the Argo buoy data.
all right, so they go to Argo buoy data. So there, but you have no standardization. You're saying, and nothing is in the literature when the scientists and the statisticians are making their graphs. There's nothing that indicates
They
the
may say
measurements.
they will say in their
Okay.
methodology,
Yeah.
we measure down to this many meters.
Okay.
But it should be that, okay, we took sea surface temperature, and if there was a standardization, everyone would know, oh, okay, it's 2 meters, what
Right.
have you.
Right. So
As
you're not
opposed to we measure sea surface temperature and we took it down to 5 meters, took it down to
Yeah.
10 meters,
So
and
you're
blah blah
right.
blah.
Right.
It
Right.
should be a standardization. That's what I'm saying. But what I'm also saying is because there is no standardization, you have to look at that data very, very carefully. Now, it's a lot easier to get the satellite data because the damn thing's always flying overhead and they immediately beam it down to your laptop, right? Whereas the Argos buoy data, they collect it,
Yeah.
and
You
like
gotta go
once a
out.
month, it bops up to the surface, it shoots a signal to a satellite, then shoots it back down to the computer.
That's really interesting. But if it was standardized, is there a baseline, Jim? Baseline sea surface temperature? I mean, obviously there's a baseline that's measured. So we're looking at the temperature getting hotter and hotter. Is the baseline established on a specific depth? It seems not.
No, I don't think it is. No,
Oh, that's interesting. So
but
science
we,
always
but we,
can get better.
yeah, but we do know that the ocean heat has been accumulating down to 2,000 meters, concentrated in the upper 700 meters. We do know that. I
Hmm.
mean, so sea surface temperature is not the only metric. You have to look at what the flux rate is,
Okay.
throughout the water column.
All right.
And
Well,
you have to look at the mesoscale eddies. You have to look at the ENSO cycles and how they impact, you know, how the ocean heat moves from the oceans to the atmosphere. And it is happening. We're actually measuring it up in the Arctic Ocean, by the way.
okay. How's that working?
Well,
Who's
we're
doing it?
measuring a bunch of researchers.
Well,
We're
yeah.
measuring. We're already measuring the flux rate of the heat from the ocean to the atmosphere. Part of the reason why sea ice is disappearing.
Yes, absolutely. I
So,
know. All right. Well,
but
let's
yeah,
move on. Oh,
that's.
sorry.
I just want the folks to be made aware of that. That's all.
No, it's good. It's good to be made to be made aware of these things and also understanding that it isn't always just one thing. But I do want to ask you one question though. I mean, you and I have discussed Amoc. We've done a bunch of things. There's new research. I guess it was what's the guy? What's his name? Paul Beckwith just came out with a video that talks about this, about with the
Ransdorf,
yeah, from the new paper. But
the guy from the PIK.
yeah, but we're not minimizing the AMOC threat. You're just saying that it's not uh, going to happen tomorrow.
Is that,
I mean, this is not like the movie. It's not going to happen tomorrow.
yeah.
But it's
No,
happening though. You can't dispute that it's not happening.
No, I'm no. Of course, AMOC is the reduction, slowdown in AMOC is happening. What I'm simply saying is aerosol is not the fucking cause. That's what I'm
Of
saying.
the AMOC. Yeah, but that's not now this I didn't read this research. So what Paul was his video today, which I didn't watch the whole thing, was not there was no attribution in the AMOC slowdown to aerosols being the primary driver. I don't know.
Well, it's because it's not.
Okay, but I
it
don't
simply
think.
is not.
All right, we'll
And I
have
get
to
sick
look
and
at that.
tired. I get sick and tired of people pushing that narrative that reduction of aerosols causing the AMOC to slow down. I'm very concerned. Well, yeah, be concerned about AMOC slowing down, but ain't freaking aerosols doing it. It's the goddamn freshwater input
All
that
right.
changes the salinity, that changes the density. That's what's going on. And it, the other implied assumption with the folks pushing the aerosol is that we've stopped putting greenhouse gases into the system. We're still burning greenhouse gases. We're still adding all this carbon,
Right.
which is warming the things up.
Yeah.
So the added carbon more than obliterates any, you know,
And he
aerosol
saved.
masking effect.
Right. Yeah. I gotcha. I got ya. All right. Well, let's move on to Arctic marine heat waves. This is the third one, right?
Yeah. Again, I will be doing a deep dive on this article as well. We'll just go over the abstract because there's some
All right.
important nuggets in
Yeah.
this.
Let me bring up this
Arctic,
question really quick. Really quick. You can't use SST to prove AMOC slowdown. Agreed, Jim? Can't use the sea surface temperatures to prove it. And this is Torstein going south from Greenland.
well, in science we don't prove anything. First of all,
Well, he's a scientist
Caesar.
too.
Well, I'm just saying. In
Yeah.
science, you don't prove anything. You can verify hypotheses.
Okay.
Um, re- Sea surface temperature is an important parameter, but not as important as sea surface salinity,
Right.
SSS.
Mm-hmm.
Because again, in higher latitudes, salinity is the driver of ocean density, not temperature. Temperature is the driver of ocean density in at the equatorial or tropical waters.
Mm-hmm. Okay.
But what we do is we drop a CTD. We drop a CTD, we get a vertical profile of the water column,
When you're
and we measure
TCBing.
it. CTT, conductivity, temperature, and density.
I know, but you're TCBing. Come on,
I
Jim,
don't
you're old. Taking care of business.
I don't get the reference anyway.
Really?
Huh.
Okay. We'll have to talk offline about this one.
But you drop a CTD, and you get a profile that through software calculation will determine the salinity, and then the temperature. From the temperature salinity you get the density, and then
Mm-hmm.
you can see the profiles. And the conductivity part is how we calculate the salinity, and then with the salinity and temperature we have TS curves and that kind of stuff, and we can get the density, so we can get a profile. And we also measure, folks go right out there in C2, and we've got flow meters in place and so on. Flow meters measure not only horizontal movement but vertical movement, and we can actually measure, what the vertical sinking rates are. And when you look at the data, we see a slowdown in the vertical
Yes.
sinking rate, which was first documented in the late 1990s. That's how far back this goes.
Which really isn't that far when you think about it, but yeah.
But it's a lot further back than aerosol reduction. you know.
True.
So
True.
yeah, so we have the data showing actual hard data showing the slowdown in the deep water formation and the vertical sinking, slow down the thermohaline flow. So the data's there.
Okay. So let's move on. Tell us what's this journal article? Arctic marine heat waves forced by greenhouse gases triggered by abrupt sea ice melt, and that's pretty scary.
It's extremely scary. And as I said,
Mm-hmm.
I will be doing a deep dive on this one as well.
All
This one
right.
is a technical one.
Mm-hmm.
Both of these are actually.
Mm-hmm.
Since 2007, unprecedented marine heat wave events, we usually abbreviate it as MHW, are occurring over the Arctic Ocean. Here we identified the fraction of the likelihood of
Mm.
Arctic marine heat wave magnitude that is attributable to greenhouse gas forcing. Nope, not aerosols. Results reveal that Arctic marine heat waves are primarily triggered by an abrupt sea ice retreat,
Oh
which
boy.
coincides with the maximum downward radiative fluxes.
Mm.
Up to 82% of the sea surface temperature variability over the shallow Arctic marginal seas. They're talking about East Siberian, Laptev, Kara, the Eurasian side of things.
All right.
Okay, where marine heat waves are prone to occur can be explained by net accumulation of seasonal surface heat flux in the ocean. Event attribution analysis demonstrates that the 103-day long 2020 event, the most intense for sea recorded so far in the Arctic, would
Wow.
be exceptionally unlikely in the absence of greenhouse gas forcing
Hmm.
in terms of both intensity and duration.
Ooh.
Our results imply greenhouse gas emissions continue to rise along with the expansion of first-year ice extent. Moderate marine heat waves in the Arctic will likely persistently
Reoccur.
reoccur.
That's frightening. Yes.
Now, what's not mentioned there, but is a major contributor to that heat flux talking about in the ocean there,
Mm-hmm.
is the North Atlantic Intermediate Water,
Okay.
which originates in the Mediterranean.
Oh.
And that water is very warm, but it's also very salty. It actually has a higher
There's that
salinity than the Atlantic Ocean.
salinity
It's about
again. Here
it's
we
about
go.
35, 36 parts per thousand. The Atlantic on average is about 34. So even though it's warm, but because of the higher salinity, it becomes more dense, so it sinks to intermediate depths down to about 1,000 meters.
Mm-hmm.
And it makes thanks to Coriolis, it makes a beeline for Fram. And it goes right into the Arctic Ocean and bringing all that heat with it.
Damn.
So you've got, just like with Antarctica, you got the ocean heat melting the cantilevered ice from below, the warming atmosphere melting it from above. So you have the warming atmosphere
Mm-hmm.
melting the ice or preventing the ice from even forming. You got the heat fluxing from below. It's getting rid of the sea ice. And then that allows, because you reduce the albedo, that allows more energy to be absorbed by the heat combined with the flux from below.
Yeah.
And you got marine heat waves.
And here's the graphics from that. These are actually pretty good. Wow. Showing the actual sea surface temperature, and then it's showing the variability here, going up and up like everything else. Are you able to see these on your computer big enough to talk about them?
Well, I've got the article here, so
Yeah. Yeah.
I can just scroll down.
Yeah,
What,
check them out.
yeah, there it is.
Mm-hmm.
Yeah, yeah, it's showing, starting how it's gone pretty much on the, and of course, you notice
I'm going back.
it's a normalized sea surface temperature. So
All right.
can't quite see what if there's a baseline here. Might be when I pull it up in the,
1980.
uh,
Oh, a baseline. I can see it starts in 82 on the in the figure B, and then C relative Arctic sea ice extent anomalies with the marine heat waves max intensity. That's an interesting one.
okay, looks like 82 to 21 is the time period in
Yeah,
question.
yeah,
So they're normalizing it to that time period.
yeah.
Okay, so that's what it appeared to be. And Yeah. So we see that. Now, remember when I did the my very first ocean heat content video, I put that graphic up there and I put a big red arrow in about the mid 1990s. And I said that was the turning point. That was the tipping point that the entire planet went past. And that's when ocean heat started accumulating. And, and when you see that,
Right.
we see that rise going over there. The total ocean heat would be an integration. You just do each year adds more
Okay.
and more, but you integrate, over that entire time frame, and you get the
Mm-hmm.
total heat, which is about in excess of 465 zettajoules. Well, remember, oceans move horizontally,
Mm-hmm. Mm-hmm.
sometimes vertically,
Mm-hmm.
and vertically upwards to the atmosphere. So now you start bringing in that heat, and it's not only through Fram, but it's also through the Bering Strait. You
Okay.
bring in more heat, right? So you're moving heat laterally all over the ocean. You're
Wow.
taking that accumulated ocean heat, which is the total for all the oceans of the planet, and you're taking that and you're moving it here, you're moving it there, you're melting the ice
Yes.
here,
Gotta.
you're melting the sea ice there, you're fluxing to the atmosphere here. It's all being moved around. You're fueling nasty storms, nastier storm, all
Wow.
right? Because starting in the mid 1990s, overall, the oceans are no longer sequestering heat to great depth. It's now accumulating in the upper layers, and it's being returned to us.
Mm. Mm-mm-mm. Wow. Yeah, that's pretty intense. I've got some questions. I do want to do these. People are asking a million questions, and so let's do that and be interactive before we go on to our next topic. All right, so let me see who I clipped. There's a lot of questions. All right, and this one, yo
Well, I hope
mama. What?
I hope you're all taking notes. It's going to be a quiz. No.
Yo, mama. How long before the seawater carving from under that Antarctic ice, before the landslides into the sea, and wait, let me get back. And after that, how long till Mr. Amoc slows enough to bring on an ice age? Got your crystal ball out, Jim.
Well, the ocean heat is already impacting the cantilevered land ice, um, because that's ice that's extended past the grounding line, so it's floating on the ocean. So it's already impacting that from below.
Mm-hmm.
So as it melts that ice and bits of it breaks off, that allows the land ice behind it to chug along and protrude further out. Also, the loss of sea ice.
Wow.
When you have the sea ice there, the sea ice kind of helps push against the land ice. You lose the sea ice, well, it's not much holding back the ice, so you
Yeah.
melt that, and that breaks off, gets moves into lower latitudes where it can contribute to sea level rise, and then the land ice behind that just moves on along until you get another bunch of ice that cantilevers over the grounding, past the grounding line. As far as does AMOC slow down enough?
Right.
Depends on the rate of slowdown. As I said before, in the past, we've had proxy data that indicates when AMOC slows significantly or shuts down totally, it's enough to trigger growth of ice sheets. However, as we discussed earlier, AMOC slowing down is going to be more of a pain in the ass for folks in Scandinavia and the UK and Northern
Mm.
Europe, because they'll experience cooler conditions. But because of all the warming in the system, because of all the ocean heat content and the rest of the oceans, I don't. Now that could be, come back in 500 years, dig me out of my grave and say, "Hey, dude, you're wrong." But I don't see ice sheets growing again because of all
No.
the heat in the system.
Yeah.
Not unless that heat gets drawn down sufficiently.
Well, that won't be. I mean, we could get to
That's
net
probably
zero, but that's not going to happen for a long time.
Well, don't forget you have pipeline warming, thermal inertia, and all that other stuff. We discussed that before.
Yes, we
What we're
have.
feeling, what we're experiencing today is the result of CO2 levels from about 10, 15 years ago.
Right.
So the CO2 levels of today, we won't feel until, you know, 2035, 2040.
All
Going to
right.
get worse.
Here's another one. The Devil's Therapist. Hello. Amoc is only one current. What about the Antarctic circumpolar current? This is also affected by the amplified heating in the Arctic and heat waves. Thanks.
Well, that is true. It's only one current, but that one current feeds a whole bunch of other currents. You got the North Atlantic deep water current that arises from Amoc sinking, which then drives other currents. And don't forget, the other thing with the North Atlantic deep water, if Amoc slows down, so does the North Atlantic deep water.
Mm-hmm.
Well, the North Atlantic deep water upwells in the Southern Ocean at the Antarctic divergence front. That upwelling brings nutrients that fuels that whole food web down there. So if the
Ah,
North
that's
Atlantic
another
deep water
problem.
slows down, all the krill and the orcas and the baleen whales and seabirds and seals, etc., penguins, they all go away. Now, as far as the ACC goes, um, there are changes happening to it. There, I forget what it was I saw, but the recent research shows that the ACC is increasing in its water transport. In other words, it's transporting more sphere drips.
Mm.
A sphere drip, as a reminder to folks, is the movement of 10 to the 6 cubic meters of water per second.
Okay.
And ACC, because spinning around at about 60 degrees south latitude, there's no landmass there, so that thing can twirl around pretty quickly, and it's what was about it's on the order about 150 sphere drips,
Okay.
which makes it the most voluminous current as far as how much volume it moves. So 150 sphere drops. That's 150 times 10 to the 6 cubic meters per second going past the point.
All right. And then so the if amplified heating.
Southern
Oh,
oceans are heating up.
yeah, yeah. They sure
The
are.
southern oceans are heating up. And
Yes.
don't forget, we also have another location for deep water formation. It's the Antarctic bottom water that comes off of Antarctica.
Which, yeah, I think he had. Hmm.
And that tends to fill in the void left by a slowdown in Amoc. You start seeing more of that Atlantic bottom water reaching further north into the North Atlantic.
Wow. Sounds perilous. All right. So I got that one.
Remember, we talk about Atlantic Ocean, Pacific Ocean,
Hmm.
whatever. The oceans, it's one ocean, and the hub is the Southern Ocean. You look at all the major currents coming in and going out. It's a big hub. They come into
Hubba
the
hubba.
ACC and below the ACC, the Antarctic deep water current, and so on. It's all a big hub. As the Antarctic, think of that as the grand central of the oceans. Everything, all the currents come in there. They spin in, spin out, whatever, and it's a way to connect all
Hmm.
the oceans.
And they are slowing. But it's not from aerosols. It is from heat. It is from carbon in the atmosphere drawing the heat in
Carbon in the atmosphere,
to the oceans.
and it's
Yep.
from density differences.
Yep. And the salinity. There
Yep,
we go.
part of the density. Yep, exactly.
All right, guys. Listen, we've been an hour. We have an intermission video because I have to stand up and I hurt myself everywhere. We're going to watch an intermission video. Then we are coming back with part two, which is the Twitter wars, which is actually, we're going to talk about blocking. We're going to talk about why this happens with a certain scientist. We're not disparaging anyone, but this week it was Sabine, Elliot, Sandy, and Jim, who got us, really got in this. It's ridiculous because I don't fight with anybody. I don't like
Elliot,
to.
Elliot got blocked by him.
Well, his was he's been blocked for a long time, but his was the first assault. And then it was Sabine. Yeah, it was Sabine Hassan Fell, what's her name? The physicist. Sabine, she was on Twitter. It's the same shit happened to her. I don't know what's with my camera moving. All right, let me get the video on, guys. Intermission. I'll set it up. Yeah, it was all of us. All of us, Jim. It was
In stage one,
week.
we say
It was a tough week. All right. See you after.
I thought it was funny.
Yeah, it's funny. It's funny, but it's annoying. And you guys watch the video. Yeah, Sabine was mixed up in this. All right, watch the video. It's actually, let me tell you, I've been collecting clips and making videos for years. So there's a lot of stuff. Some of it's kind of poor quality, but it's old. Just watch and enjoy the intermission, even if it's not the best quality.
in stage one, we say nothing is going to happen.
Stage 2, we say something may be going to happen, but we should do nothing about it.
In stage 3, we say that maybe we should do something about it, but there's nothing we can do.
Stage 4, we say maybe there was something we could have done, but it's too late now.
You may have heard of this. The world's oceans are alarmingly hot right now. In fact, far above records for this date. And the math tells us that what we're seeing should be statistically impossible in a quote-unquote normal climate, but our climate is no longer normal as climate heating has loaded the dice for more extremes.
We are the Rodney Dangerfield of the world. We don't get no respect, the doomers. We don't get no respect. And It is tough because I think that the people that I've met in this whole sphere are the most enlightened, intelligent, caring, and compassionate people. And so I think it really we get a bad rap, and we're getting it now.
You see so many narratives these days. It's sort of compelling, almost fictional narratives describing our portending doom. It sells. We call it climate doom porn. I think people who read it sort of almost provides adrenaline, the same adrenaline you get from watching an action disaster film. And so it's unfortunate that it's become so prevalent because so many of these doomist narratives are based on a distortion of the science.
If the Earth gets too warm, for example, ice caps could melt, raising the level of the seas.
Possible, probable, we really don't know. But if it happens, it means goodbye Miami, goodbye Corpus Christi, goodbye Sacramento, goodbye Boston, goodbye New Orleans, goodbye Charleston, Savannah, and Norfolk.
The state of the planet is really dire. We have ample scientific evidence today that we are at nothing less than a planetary emergency. We have a global climate crisis, but we also have a global ecological crisis. And the ecological crisis undermines the resilience of the whole planet, which means that when we continue to emit greenhouse gases, burning fossil fuels, and degrading ecosystems, we are coming very close to tipping points, which would lead to irreversible changes that would commit all future generations to a planet that would drift off irreversibly towards a lesser and lesser state to support human livelihoods. So all in all, we are today at a point of existential challenge. And this is now well established scientifically through the IPCC, the Intergovernmental Panel on Climate Change 6 report.
It's really as bad as the distortions of the science that we're used to seeing from climate change deniers. So it's bad science, claims that we're already committed to runaway warming and all.
Arctic ice melting like Mr. Whippy on the stove. Ocean life extinguished, lightning fast like Messi facing goal. Night temperatures rising like the price of granary rolls. Psychopaths delight in buying shares in black gold. We're doomed. It's on the horizon, we're doomed. I'm not just hypothesizing. We're doomed, ignore hysterical deniers. We're doomed, our future's on fire. Paris climate talks took place at a time when global temperatures were 1 degree above baseline. They agreed to limit rises to no more than 1.5, but they got a massive shock only months down the line. Unprecedented warming at an accelerating rate. February's warning failed to reignite debate. Nobody's talking, not even heads of state, about the mass extinction that is clearly underway. Species disappearing at a speed we've never seen, but Brexit fills magazines and the screens on our TVs. Starbucks Costa coffee cups fill our lands and seas between. Plankton replaced by plastic on which everything else feeds. Should we leave or should we stay? It is a trivial aside from the real issue today, which is how do we survive in a world with stagnant oceans in which everything has died, in a world submerged by high tides where remaining land is fried. Population explodes as ice caps recede. Fresh water under threat, bringing society to its knees. Drought-starving farmland, way more than we've ever seen. Trout, carp and salmon, seahorses disappear. We thought we had a century or more to face our fears. More likely within 20 years the force of nature will be clear. No sloths, bears or badgers, no plants, birds or trees, no clocks, chairs or tractors, no more humanity. We're doomed, it's on the horizon, we're doomed. I'm not just hypothesizing, we're doomed. Ignore hysterical deniers, we're doomed. Our future's on fire. Even those who know what is really going on, they've still got toasters, phones, tablets, TVs turned on. They still don't stop and think about the impact that they're having. And I'm the worst offender, just like you and all our families. We just can't be trusted with products to consume. Democracy plus media means America elects a fool. This leads me to one conclusion, it's unfortunate but true. We need a global dictator, but one with benevolent views. A person versed in science who'll silence corporate news. Their military might only exercise to stop us lighting fossil fuels. And once that's all sorted, just one thing to finally do. Throw a solar panel, say good luck, go find some food. It's not a happy future, but let's not be blind to the truth. The earth is changing faster than any time, what can we do? We're all much too distracted, half of us don't even believe it's true. While endless wealth is extracted from our addiction to dirty fuels. We're doomed, it's on the horizon, we're doomed. I'm not just hypothesizing, we're doomed. Ignore hysterical deniers, we're doomed. Our future's on fire.
Just the people who attack us are going to attack us. They can't help but attack us. There's no other option for them psychologically because it's just too excruciatingly painful for them to realize that we're already in contraction and collapse. That's why.
In stage one, we say
All right.
nothing is going to.
I hope you guys liked the intermission. Okay, so for me, it all started back in 2020 when I first heard what Dr. Mann was saying, and I was so naive. I was in shock. I never thought, okay, the doomer narrative was kind of whatever it was, but following the right science. And yes, we've done many shows using IPCC data. We felt that the IPCC might be a bit conservative in what they showed, but nobody ever thought, and this is what Michael Mann was saying on Twitter, that I literally was saying that when you said, remember your comment was about the article that Obsolete Optics Brett shared, said the Arctic was heating 3 times the rate.
Right, yeah.
Okay, and you said no 4 times and maybe 5 in some places, and then you said IPCC strikes again. Now that must have made him crazy because he thought you were saying like a conspiracy, like the IPCC is nefariously misleading everyone. Now, there are those that will say that, oh, they're just doing it because we need to spend, and lying. But these are scientists, distinguished scientists. So I would never say that. But that's what he asked me if I bought it, like it was treating this like a conspiracy. I'm like, no. And science, like you said, Jim, science is to be debated. And I'm not pulling up all the graphics because anybody that's following that's been involved in this saw it. It's just the whole point is science is about debate. And I want to say about the particular individual is that I feel that because he was, and you didn't even know this, he just won $1 million lawsuit because of defamation that's been going on for years. I mean, he was dragged through the mud. He was defamed. It was a horrible defamation and all that. And I think what it's done is it's made him paranoid. But when you summarily dismiss people and alienate them that are just questioning, not accusing him, because the science. What were you saying to me earlier about the science?
You know what, that we should be, the scientists should be open to debate and discussions.
Yeah, but his science, you said years ago, I mean, it was good. Good
yeah,
science.
yeah. Some 30 years ago, he did decent science. And that to me is probably more, if he was just a crackpot all along, okay, he's a crackpot, but he did decent science, and to see where he's at now is, I actually think is distressing.
That's
really
what
do.
We all think, and I'm not disparaging or tarnishing his character, but he has done that with a brushstroke with so many of us, and I think that's what is tough. So I found a couple of articles that
what gets me is that in a lot of his statements, it seems he's forgotten basic physics. Like when he says, net zero will stop the warming. Dude, we got thermal inertia in the system. Right. We got the ocean heat. I see things like that, or these other really non-realistic approaches. I'm just like, where's this coming from? And those who know, who are familiar with my work, what have you, everyone knows that I'm on record as saying that the IPCC is notorious. I'm not saying nefarious. I'm saying notorious for underestimating things because they keep assuming linearity when we know that that's not the case. I mean, now we're seeing, more and more researchers are using the RCP 8.5 approach as opposed to the 2s and the 4s and the whatever, because, well, that's what the data, and even that, the 8.5 is still an underestimation, but it comes the closest, and the 8.5 is an exponential one. The PIK group has been doing exponentiation models for decades. Is why I still think they're the premier, overall climate research organization. So, it's, and the IPCC, I've had to deal with them. They're a political body. We need to keep that in mind. They are a political body, which means they go to the lowest denominator.
What's their funding?
I don't know.
It's very broad. I had it, but it's too much to go into the show. So, right now. All right. So you want me to?
I mean,
go ahead.
When you see, for example, like these COP meetings, funded by the fossil fuel companies. Good God.
Well, I know, but I think the IPCC is a little more. It's more academic. I do think it's it's not a conference.
It's you a lot of contributing scientists, no doubt, but it's also very political.
Right. Well, I found this.
And we all know how politics fucks things up.
It certainly does. It's too bad that climate and our overshoot and our ecological issues became a political thing. However, I wanted to look at this. There's a couple of things that this was a book review, and I found that it was interesting because the book was called Climate Wars. And Michael Mann has been in the climate wars for well over a decade now. As he reminds us frequently in his new book, he's been in the crosshairs of his enemies, has fought off the attack dogs, and carries the scars of the battle. Even environmentalist Bill McKibben's promotional puff for the book valorizes Mann in terms of scars from the climate wars. So the military framing of climate change long predates Mann's involvement, but it is certainly is a framing he has done much more to promote through his blogs, tweets, and general persona at large in Discord. All right. So what I want to do, I want to go down a little. I'm not going to read the whole thing, but it's actually got a lot of good pieces in it. It's characterizing of the politics of climate change through a series of complex military tropes and metaphors, wars, battles, attacks, fights, and enemies litter its 260 pages. This is a critique. It's a book review. The person, but what I want to, and then Mann and his allies are now having to fight against the forces of inaction. So I need to do some kind of video with Michael Mann in an inaction, fighting in action. But he's half right in his diagnosis. The main axis of political dispute and our argumentation about climate change have changed. The politics of climate change manifest differently now than they did a decade ago. And that's true, correct? So the focus of the issue has moved from is there a problem to what should be done about it. But what I really wanted to go down in this was he assesses solutions, of course. He doesn't like things that we don't like. I mean, it's freaking me out because we don't like carbon dioxide removal. We don't think it's going to work, right? Direct air capture, all this horse shit. But then afforestation was in there, and that was a hard one because those are good things. I don't agree with this person on nuclear energy. But this is what I want to get to. Mann unhelpfully identifies 8 alliterative groups of enemies. Enemies. And we're all into science. We're not enemies. Under the battle flag of inactivism. Dissemblers, deceivers, downplayers, dividers, deflectors, doomers, delayers, distractors. Simple deniers now is not enough. His circle of enemies has grown, mutated, and perhaps most sinister of all, infiltrated the climate movement. I can't even imagine how I have infiltrated anything because I ask questions. The same with you. But he finds it necessary to create enemies out of a variety of scientists, scholars, writers, filmmakers, and think tanks that are actually engaged in the serious search for solutions to climate change, not just his solutions. So, he disagrees with people. And then I want to go back move down to, all right, the battle plan has 4 elements. Resist the doomists, learn from the children, educate the uneducated, and focus on systemic change. Are any of those horrible? Except for the doomer part. Because, the conversation should not be summarily dismissed. I'm sorry. We see what's happening in our faces all the time. All right.
Well, it's like I'm usually accused of being a pessimist and a cynic, and my retort is, no, I'm just being a realist.
Yeah. And unfortunately, the term realist has been hijacked by the Heartland Institute. And they have a raging denier newsletter called Climate Realist that Michael Mann probably knows about and hates because those are the people that really attacked him. It was a self-fulfilling prophecy for the doomers to flip out. And I got over it in 2021 when Michael Dowd told us to love him. But anyway, so 4 points. Okay, the final one, changing the system requires systemic change. Who doesn't agree with that? But now systemic change can mean different things for different people. But for man, it means pricing carbon and promoting 100% renewables for meeting the world's energy needs. Other technological innovations seem to be ruled out by him. This is certainly not what some climate activists such as anti-capitalist Naomi Klein or the young Swedish environmentalist Greta Thunberg would mean by systemic change. And it is notable that while he is willing to challenge Klein's position, he works hard in the book to keep Thunberg inside his circle of the virtues, the virtuous. But it's basically he doesn't want to build. That's what the problem is. He's uninterested in building alliances necessary for political change, which I thought was really a good assessment here. He's not going to make change or bring change if he alienates so many people. All right, it's an America First book. He offers little for those seeking guide to the complex global politics of climate change. So there's a lot here, and I will have the link. But I have another. Go ahead.
One thing I want to point out: look at the that little insert quote there that's in green.
Yeah.
Consistently demonizing those who think differently than you makes it harder, if not impossible, to forge alliances.
Yeah, which is exactly what the right wing in the United States has done to everybody else. We're
exactly.
We're commies, we're demon rats, we're whatever the hell they want to call us. I mean, and I don't demonize MAGA. I make fun of them. I think people are morons, but I don't demonize them because they're victims of propaganda, gaslighting, manipulation, all the other things that you can,
I have a new meaning for that acronym, MAGA.
You do?
Yeah, make assholes go away.
Right? Okay, well, I just thought of something, okay? Since we're on MAGA, right? Let's give MAGA the Environmental Coffee House Flush of the Day. All right. So
if only with that simple.
I know, right? The next article, really quickly, is in this one also. This is from Sustainability for All Tree Hugger, and they write quite a bit about Michael. And this was from 21, and I wanted to go down to where. See, and this is another thing. I have this graphic. Let me bring this graphic up really quick. And you see that William Rees, he was the person that came up with like the carbon footprint. The term, about the carbon footprint, it was coined by William Rees, an ecologist. It's a useful way for us to gauge our individual impact on the environment. Now, of course, polluters would love to use this idea to put the onus on consumers to consider their choices only in isolation. They would rather have that than people asking why the companies directly polluting don't do better. In truth, the destruction of the biosphere is a collaborative effort. Okay, so we all know and love Dr. Rees. I want to point out a couple of things about another thing I don't agree with Dr. Mann. I work very hard here, growing food, trying to do the right thing, and living a cleaner life with a lower carbon footprint where I can, and this article talked about that. It's not that what I do doesn't mean anything. There's a hypocrisy there, Jim. So he claims the emphasis on small personal actions can actually undermine support for the substantive climate policies needed. Tree hugger commenter Greg even did a hilarious meme about the argument in a recent post, asking, "That is even a question?" So it's a false choice between individual behavior change and systems change. They say that system change and individual behavior change are not conflicting frameworks for how to mitigate climate change. They are two sides of the same coin. Remember, this was written a few years ago. I don't even know. Are we talking about mitigate? I mean, what are we talking about anymore? But in any society, individuals drive social norms that make up the collective culture. For instance, cultural revolutions don't happen because of systems change. They happen when a group of people voice a compelling story that propagates across society and becomes a social norm. And personal habits contribute to climate change, can orient us towards advocacy for aligned policies and practices. So it's right. It's both. And I'm not going to feel bad about the things that I do because somebody says, well, that's just what the fossil fuel industry wants you to do, because then we corporations don't have to do anything. So both sides are valid. And therefore, it is not a choice between the two. We need to do better as individuals, and we need to pressure politicians and companies to adopt policies and practices that speed up the transition. That's what this is saying, to a sustainable economy. And the question of individual behavior change versus system change is a false dichotomy. Lifestyle choices are enabled. I already read that. But history is full of heroes and communities that have come together to defy the odds. Whether or not you think this is hopium, it's we still feel like that. At least we support that on this channel. It's both things. We can't keep blaming 100 fossil fuel companies for 71% of the carbon emissions. Over 90% of those emissions come out of our tailpipes, chimneys, and smokestacks. We are buying what they are selling. Yes, we may not have the opportunity to do anything else, though. That is true, right? I mean, Jim, we can't all afford to go out and have. Even some of us don't even have homes,
Yeah.
So it's not changing over to all renewables it's not happening for people because it's not being done in a way that would have made
Plus,
it
a lot of people
soft landing.
don't have the capital. I mean, for example,
No, that's what I'm saying. Don't have the money because it's not nationalized energy, which we should be.
I mean, for me to put solar on my house,
Mm-hmm.
I have to outlay close to 40 grand. I don't
Right.
have 40 grand.
No, I don't either. But if it was if energy was nationalized and this was done instead of taking solar, 800 acres like they want to do in where I live for solar farms, and made it where it was retrofitting people's homes and looking for less, harmful ways of mining and all of that. But it's not done that way. It's done for maximum profit.
I just saw a study, or an article, not a study, an article where saying that solar panels that were put on like 30 years ago, when the technology was nowhere as it is today,
Mm-hmm.
are still 79% efficient.
Hmm.
So a 30-year-old, piece of equipment,
Mm-hmm.
based on technology from 30 years ago, is still 79% efficient.
Right.
Now, how many furnaces and boilers,
Not.
especially, approach a 79% efficiency, especially
No.
from 30 years ago?
No.
No.
But can you imagine?
So
We could have been so far ahead of the game, and nobody's arguing.
Jimmy
about
Carter
that.
tried to warn us.
I know.
He tried to warn us. He put solar panels on the White House, and Ronnie Reagan tore him right down. And so now you've got the fossil fuels, because they're just looking quarter to quarter. What are the profits quarter to quarter? They're going to fight tooth and nail until every last damn drop is sucked up out of the ground, and then they're going to resist changing over, because it means they're out of business.
Yeah.
Now, if they were smart, they would actually take some of the damn profits that they have and help with the
Right.
transition.
Of course. Of course. This person says, in the end, I believe that individual actions matter because we have to stop buying what the oil and car and plastics and beef companies are selling. If we don't consume, they can't produce. It makes a difference. I think it does to a degree. I mean, I don't think is it going to solve the predicament? Solve a predicament, right?
Well, the thing is, though, okay, it's one thing to say, oh, if you don't buy what they're selling.
Right.
If you have a job, you got to drive to work,
Yeah,
right?
I know.
So you need a car. You need to put fuel in the car. Or you have an electric vehicle. You need to plug it in at night. How is your home power supplied? Coal, diesel, natural gas? I mean, it's a little naive to say, oh, just don't buy what they're selling. Well, we live in a society where by necessity we have to. If we,
But those
now
are those are the things we
now
have to change if it's ever going to happen. I had Roger Hallam talking about the activism part of all this. There's just so many
yeah,
things.
you have to change the politicians' mindset. You have to get the corporations to change their approaches. Yeah, we can put the pressure on them, but until there is, a systemic change, as you rightly say, until there's a systemic change, all the individual efforts are not going to amount to a significant reduction.
But we still should do them.
I sit here in my house here, because I'm retired now, so I don't have to drive to campus every day to go to work. I drive basically the town once a week. That's to get groceries.
Yeah, like me. I never go out much.
Otherwise, I stay put. I take my daily walk. I don't go anywhere.
Right.
Or the other trip to town is to go get a load of water. So I'm doing my bit because my water usage is about 150 gallons a month.
That's okay. All right. Well, I'm just looking forward to see if anybody has any comments or questions on that one. We weren't looking to assault the guy. It's just absolutely crazy that. All right, or
by the
it's
way,
got to be his way or the highway. Actually, that's wrong.
By the way, when I made that comment about the IPC strikes again, I didn't even know he was in on that thread, on that convo. I didn't even know that.
Well, I didn't know either. How would I know? I don't even know if Brett made the original posting of the article, the research on the Arctic, and talking about the heating, and I have no idea how he got it. It seems like, and then he's a block machine. This was a big thing on Twitter, and it started with another channel called Climate Chat, who had Dr. Mann on as a guest. Well, it was hard because Dr. Mann did get a little bit ganged up on by the host, which I don't do. I don't do gotcha journalism. I don't do it. And I don't even know if they really did it that much, but I know the chat was hot. People do want to get mad at him, but he brought that on himself by not making allies of the people he's disparaging. You're disparaging me and Jim, how stupid is that?
Yeah, I've been to my share of scientific conferences, and I've been to a few plenary sessions where it got really heated.
Yeah.
The arguments ensued, but you know what? At the end of it all, let's go have a drink. Let's go get a beer.
Well, it doesn't seem to be.
It's like, I'm still going to disagree with you on that. I don't think you're looking at that data correctly, blah, blah, blah. And, but, that's
right.
Science. That's how science is done.
Yeah.
Believe it or not, that's how it's done.
And Nature has a new article about the IPCC and how they're starting to ramp up and do some. And so, of course, it's going to be different. There'll be more data, updated. So, and there'll be debate and there'll be discussions. I'm done with it.
Maybe they'll actually revisit the scenarios that they use, some of the assumptions that they use. Maybe they'll revisit that and make the appropriate adjustments. We can only hope. But until they do so, I tend to be dismissive of them, to be quite honest.
All right. I'm looking for something.
They've gotten so many things wrong. It's just,
So, where the checks and balances aren't the checks and balances each other?
that's how ideally the system's supposed to work. But remember, it's a political body, and then
Yeah.
they get the administrators, and then they start doing the political nonsense, and it waters down the science. It
Well,
just does.
here's one. It was the idea that the IPCC is part of some vast conspiracy used to be a talking point of the climate denying right, but now, and there was nothing that would say that your comment was a part of saying that the IPCC is a conspiracy. It's just ridiculous, and it was just her. It was just awful.
When all I'm saying is, you look at the reports that they put out, they underestimate things. They give short shrift to the oceans. They don't give the ocean its due as part of the climate assessment and analyses.
Right.
So that's, is that a conspiracy? No, it's just that they're just consistently getting it lowballed.
Well, yeah, and I don't think that's a horrible thing to say.
I mean,
don't.
it's one we question it. I'm basically
Everything.
questioning the methodology.
Hmm.
When you constantly change the baseline, that is not good
And
methodology.
that does
It makes
happen. I know that's been a controversy. We've talked about it.
Yeah, but so
Antonio.
I'm not. Doesn't mean there's a conspiracy afoot that they're doing this deliberately. It just manifests itself that in that manner because the change in the baselines, they're using linearity. It's just the methodology is wrong. It's perfectly okay to question methodology.
Yeah. Brett says the IPCC admitted themselves that climate change is abrupt. SR4, SR5, SR6, and irreversible. But if you can't tell the masses that on CNN. And you remember, you know that Elliot Jacobson was a guest on CNN, and he doesn't think he'll ever be asked back because he doesn't give a narrative like Michael Mann. And Michael Mann is actually, he does write books, makes lots of money, won $1 million in his lawsuit, and he sits in the ivory tower. He was pissed off at me. I know it because I made a comment about principal investigators. I don't know if I pulled it up or not. And I think that's what pissed him off about what I said. Let me find it. It was really about, okay, I was an HR director in research in higher ed for 22 years. I worked with a lot of principal investigators who bought a lot of money into institutions. The hubris could be overwhelming, and actually, I'm quite sick of it. That was probably what pissed him off. But hey, this is what happens. People get changed by the amount of money. It's called when you bring in grants. If he's the director of a department, somehow there's some grant writing, unless the institution is supporting him because of the I don't know. Do his books? Does Penn State profit? I don't know how it works. I just know how grants work. There's indirect costs. The more money you get from these different grant sources, indirect costs are negotiated with the institution. So these hoity-toity principal investigators that bring in a lot of money walk around like they're king shit up in the ivory tower. I know, I lived it. And so his attitude on Twitter reminded me of that shit. And how does he have an academic position where he can sit on fucking Twitter all day and do this
Yeah.
shit? Sorry.
Well,
Said I wasn't going to do
I
it.
can tell you from personal experience, from with my colleagues and stuff like that, we spend more friggin' time writing goddamn grants that are going to a bunch of anti-science idiots in Congress, telling them, asking them to fund our studies. When these idiots who don't know diddly squat about whatever it is, and let alone climate and the deniers, and they're going to mete out crumbs to us. Come on, I mean, the system is we need to get away from this. You have to write grants to get money to do your damn research kind of stuff.
Yeah,
Yeah,
but that's
yeah. I got one of those today. But, yeah, no,
I know,
I'm in the
I know.
club. I'm
I
in the
know.
club.
So that's
But
and we wanted to get this out because there's nobody harmful here and nobody's disparaging him. It's just annoying. And it's a joke on Twitter. I mean, it's a joke on X in the scientific community or the doomer community, whatever you want to label us.
I mean, it's just well, as Sarah Duma girl, she's
Mhm.
like, "Damn, Jim, you, you got blocked. You're a scientist, not us uneducated doomers." It's like, well,
She's educated. Doomer
yeah,
girl's
she's
going to
she.
be she's actually going to be a guest.
Oh, cool.
Yeah. Yeah, she's cool. I love all these interesting, wonderful Twitter X. If you don't get addicted, sometimes I do, can be a wonderful place if you stay with the certain specific people. How Dr. Mann got weaved into that, I don't know. I don't know. I didn't look to see if
But
he was.
yeah, it's just riding the grass is like a major pain in the ass because
Oh, he
it
was on
detracts
that.
from.
Wait, Obsolete Optics did put him on that original tweet. But it wasn't it wasn't a bad one for Brett to do though. The whole the he didn't. The original one was just sharing a science article and he CC'd everybody. It was your statement that pissed him off. You shitsters! You're all shitsters out there, Jesus Christ.
Well, as the old
Uh,
saying goes, deal with it. But anyway, it's just going back to the grants there. I mean,
yeah.
we spend more time putting grants together than we actually do doing science. For goodness
Well,
sakes.
I know. I did grant writing. I did all of it, but basically most of mine was HR. But I understand the costs. I understand the whole mechanism because I did. I also wrote budgets for projects, but it's. I know
Yeah,
it
it's
should be
it's a
different.
major pain in the ass.
Yeah, but you
It's
hire grant the higher up you are, you hire grant writers. The institutions have grant writers you can go to. But if you don't have
Not at
grants,
UAF.
no, you had to
You,
write them yourself, all of it. Right, because you
yeah,
weren't
yeah.
in the position. You were not in the position. So,
We're not Ivy League nonsense, and that's that stuff. Yeah, I mean, UAF may be America's only Arctic institution, but we're still a small institution.
or
You know?
there's always Boulder. Yeah, yeah, they do so much. When Jennifer's with me, it's all we read articles where the scientists are from the Snow and Ice Center in Boulder.
NSIDC, NCAR. Oh yeah, the whole
Yeah,
alphabet
yeah.
soup down that way.
All right. Well, anyway. Oh, Keith. All right. Should I put up Keith's little where is it? Keith had a comment. Now I don't see it. God damn it. Hey, feel free to give me super chats, guys, by the way. I have a project I need to do for my house. All right. I never beg for money. I'm just not that person. All right. I can't find it. It was a good one. Damn it. Keith, where is it? Anyway, he was talking about why these things happen because he's like the he's like the centrist climate change guy. It's funny. Tom Hartman used to have he's had Guy McPherson on his show, and now Tom Hartman has Michael Mann all the time. It's changed so much that you can't bring other voices on, it seems. I don't know. What do you
I
think?
remember. I remember. Oh, I was watching one of Hartman's
I
programs
love
once,
him. Yeah.
and someone called in. I was talking about climate, whatever, and someone called in and said, "You really need to check out Jim Massa. He's this oceanographer." Blah, blah. I was like,
Are you
I was,
sure it
well,
wasn't me? Because I called in a couple of times to do those kinds of things. It wasn't me?
I have no idea.
It might have been because I think I did.
It's like about a year or so ago,
Yeah, I
maybe
think it
longer.
was me.
But
Mhm.
it's just like, and Tom was like, "Well, I don't know who he is." Blah, blah, blah. And
Well,
I'm
you
sitting there
have to
listening.
learn.
And I'm like, "Wait a second, did I just hear that right?"
No, I called twice and asked to bring specific people on. It might have been Mike. I don't know if you heard my call, but it was. And I don't even listen all the time. I don't.
I read his daily column, but haven't really been watching his
Well, he's
program lately.
important. Don't have time to watch many. I'm out with headset on. I listen to specific things, but anyway, I think that we have had a pretty good show. What do you think, guys? Are we good? We good to go? I mean, it's almost 2 hours. Woohoo! Let me thank Nadia, who is back from her trip. Nadia, thank you for the super chat. She's back from Zurich. It hovered comfortably between 15 and 20 there. I'm already dying in the 27-30 heat upon arrival to New York City Celsius. Well, it's good to have you back, sweetheart. We're happy that you're back. Let me see.
Oh, that's the same temperature here in Fairbanks, 27 to 30 C.
Oh, boy. Really? Holy shit.
Yeah.
Wow.
The record high for Alaska is 40 C.
Here's a question. I'll put this one quick one up. So, do we think that, talk about man, is he afraid because of his past threats that they may still be coming? They are still there. Oh, no, they're still coming. People, are you kidding? There were, on my thread, which wasn't meant to be horribly disparaging, there were deniers that said, man is terrible. He said that. And I looked at their profiles. I said, well, you and I are not on the same side of the aisle, but you don't like man. I'm like, no, I didn't say that. I don't like the behavior. It offends me. There. I was offended. Highly offended.
Is he afraid? I don't know. I'm not in his mind.
No. I mean, he knows the deal, though. You learn to collapse acceptance if he can even understand that. I mean, does he think it's going to happen deep down inside with all the data he sees? Or is he that, consumed with the mainstream narrative that business as usual? I don't know.
Well, what's that saying that it's hard to get someone to go against something if his paycheck depends on it?
Oh boy,
something like that.
Yeah, well,
I'm totally butchering but it's
I know
that
what
kind
you're
of a
saying. Yeah, and he's a capital. I mean, totally. In the system. So, and I'm not putting that down. So was I for a long time. But anyway, guys, I want to say thank you, Jim. Thank you so much for being with us. I thought it was cool. I enjoyed the show tonight, even though I didn't do my deep dive studying. I'll have to watch your videos when you make them.
It'll be well. We'll get around to it.
All right.
Well, thanks
guys.
everyone for joining us.
Don't forget.
Stay cool.
Everything's in the show notes and Science Talk with Jim Massa.